Okay, so this lesson is your next geometry lesson, discussing quadrilaterals, triangles, polygons. This will be Unit 26 in your Mentoring Minds. First we're going to look here at your quadrilateral family tree. You should have used this video to help you just take a peek at the different types of quadrilaterals there are. First of all, you need to know that quadrilaterals are all four-sided figures. I'm just going to play a little bit of this video for you.
Look at a common quadrilateral and talk about the ways to describe this quadrilateral. The same strategy can be used for all quadrilaterals in helping to describe their properties. So let's start with this square. We're going to label our square. And we see that we have four sides. So we're going to label it A, B, C, and D. So we have our square, A, B, C, D. And that means it is a quadrilateral because it has four sides. All the sides are congruent, meaning equal. So we're going to use these tick marks to represent congruent sides. So far our square has four congruent sides. Now since the sides are congruent, we can check to see if we have parallel lines. We remember that parallel lines are lines that are the same distance apart and never cross or intersect. So we have line segment AB is parallel, that's what those two lines mean, to line segment CD. And we have another pair of parallel lines. Line segment DA is parallel to line segment BC. So let's look at inside the square at the angles.
Okay, I'm going to stop that right there. I want you to make sure that you know the different quadrilaterals. Okay, so the next thing you were supposed to do is know the different types of triangles. And so there is a sheet right here. You should have already watched this video, the triangle video, and filled in what you know on this sheet. We're going to watch a little bit of this triangle video. Hopefully you've already seen it.
When each angle is less than 90 degrees, we've got an acute triangle like these. And when one angle is more than 90, it's true. We call that triangle obtuse. The longest side is always opposite the largest angle. You can be confident if it has a 90-degree angle, a right angle. We call that guy a right triangle. You can spot it because of the little square. You'll see it inside the right angle right there. Opposite the right angle is the hypotenuse. It's the longest side. And the other two sides are called the legs. Nothing fancy there. I love triangles. Scram if you're a square. No matter the type. One thing is crazy. A triangle's angles add up to 180. What? This triangle is acute. Right triangle obtuse. Isosceles, scaling, equilateral. Now you know the whole team.
Okay, so this is the sheet you should have filled out based on that video. I just want to make sure you have the right answers. An equilateral triangle is a triangle with three equal sides. An acute triangle is a triangle with three acute angles. So there's an acute, there's an acute, and there's an acute. And if you remember from the videos, these little slash marks mean that they are all the same size, so they are congruent. An obtuse triangle has a triangle with one obtuse angle. Remember, obtuse means it's more than 90 degrees. A right triangle is a triangle with one right degree angle. So there's only one. Okay. An isosceles triangle is a triangle with two sides, though they're the same length. So remember that these slash marks mean that they are congruent. So these two sides are congruent. They are the same size, and this side is not the same size as them. So therefore, there's only two sides that are the same length. And then a scalene triangle is a triangle with zero sides that are the same length. That's why you see no marks. Okay. All right, so the next thing we're going to do is look at the other side. This side is the triangle side. We just covered that. Now we're looking at the back side, which is polygons. You were supposed to have watched this video here with the polygons. We're just going to play it real quick, some of it.
Prefix tells us, which means a word added to the beginning of a word, tells us the number of sides in the figure. So some examples of two-dimensional figures are a triangle. This is a triangle. It has 3 sides. The prefix. These two four-sided shapes, which are quadrilaterals, and the prefix in this word is quad. So quad.
I'm going to pause that there. I don't know if any of you have a four-wheeler or anything like that. Some people actually call it a quad. So if you do have one, quad is the prefix for 4.
Would mean 4. So quadrilaterals are four-sided figures. We have a pentagon. This has 5 sides, and the prefix for pentagon would be pent, P-E-N-T, pent, 5 sides. And then we have here 2 figures. This is a 6-sided figure, which is called a hexagon. This is our prefix, which would tell us that it has 6 sides. And we also have this 8-sided figure, and the prefix is octagon, 8 sides. Now another way we can classify two-dimensional figures is by looking at the angles. The name of one of the angles is this one here, a right angle. And this angle is important because it is to be used as a benchmark angle to determine the other types of angles. So a right angle creates a corner of a square, and it measures 90 degrees. When we place our benchmark angle on another angle, so there's our other angle, and our benchmark angle is the right angle, we can name this other angle. So we see that this...
We're going to pause it right there. I want you to take a look at your polygons sheet. I just want to make sure that you have the correct answer. Okay, so we're looking at your polygon sheet. We have the first blank says a polygon that has 4 sides. So if you look at this figure, all of them have 4 sides. That is called a quadrilateral. I want you to know that quad is a prefix for 4. Okay. This here shape is a rectangle. It says a quadrilateral with 4 right angles. So you can see the right angles. 2 sets of parallel sides and opposite sides are congruent. So this side and this side are congruent, and this side and this side are congruent. Okay. And these 2 sides right here are parallel, and these 2 sides right there are parallel. Okay. So you have a square, a quadrilateral with 4 right angles, and all sides are congruent. That means they're all the same length side. Okay. You have a parallelogram. It is a quadrilateral. So if you notice, all these are quads. A quadrilateral with opposite sides parallel. Okay, so that means these 2 sides are parallel and those 2 sides are parallel. And then opposite sides are also congruent. So it's very similar to the rectangle. Okay. All right. And the difference between the parallelogram and the rectangle are the angles inside. The rectangle actually has 4 right angles, and the parallelogram does not have any right angles. So that's really the only difference there. The next shape is a rhombus. Okay, it is a quadrilateral. It's a 4-sided figure. All sides are congruent, and opposite sides are parallel. Now this is very similar to a square. However, if you look at a square has 4 90-degree angles, 4 right angles, and the rhombus does not. Okay, a trapezoid. A trapezoid it only has 1 pair of parallel sides. For example, this side and this side, those are both parallel. Okay, so they would run all the way However, if you looked at these two sides to see if they were parallel, eventually if they kept on going and kept on going and this side kept on, they would eventually intersect, which means that they are not parallel. So there is only one side, only one pair. So there's a pair. Pair is two, remember? So there's two lines right there that are parallel. Okay, all right, so then the next shape we've got is a pentagon. In the video specifically talked about the pentagon. Pentagon is a five-sided figure. Then we have an octagon. An octagon is a polygon, 8 sides. Okay. Okay, so we are looking at Unit 26, Introduction. It says, number 1 says, draw a quadrilateral. So we know that's going to be a 4-sided figure. Draw a quadrilateral that contains exactly one pair of parallel sides. Okay. In your head, I want you to think of what polygon that would be. And I think that you should be able to tell me some of the quadrilaterals off the top of your head. If you need to look at your quadrilateral family tree, that would be fine. And you can also look at the polygon sheet if you need to. So a quadrilateral that contains only one pair of parallel sides is going to be a trapezoid, okay? Okay, and then it says place X's on the sides that are parallel. So this side and this side of the trapezoid are parallel. And remember that these sides will not be. So that's only one pair because remember pair is 2. And it says what is the name for this figure? Okay, and so we're going to write trapezoid on the line. Okay, so number 2 says what quadrilateral, remember quadrilateral is a 4-sided figure, what quadrilateral always, that's very important, okay, always has 4 right angles and 4 sides that are the same length. Okay, so there's a lot of important words there. Okay, so you can look at your quadrilateral family tree, you can look at your polygon sheet. Most of you should be able to tell me off the top of your head that a 4-sided figure with all sides that are the same is usually known as a square. But we need to also think about the part that says 4 right angles. Does a square have 4 right angles? Let's draw a 4-sided figure. Okay, they're all congruent, all sides are the same. Let's talk about, oh, there is right angle, there are 4 right angles right there. Therefore, the quadrilateral we're looking for is called a square. Okay, we're going to skip around a little bit. Let's look at number 4. It says draw a rectangle in the space provided. Okay, so we know that a rectangle is a 4-sided figure with opposite sides that are congruent. Okay. It says then draw a diagonal line segment, and we know that a line segment looks like this. There's a line in between 2 endpoints. Okay, I'm sorry, let me move that down. There we go. That's what a line segment looks like. It says draw a diagonal line segment from one vertex to the opposite vertex. What shapes were formed? So there's a vertex, there's a vertex. So we're talking about a diagonal line. I am actually going to use a sticky note to make sure I draw a straight line here. Straight line between those 2 vertices. Okay. All right. So then it says what shapes were formed. Okay. Oh, it looks like there's a triangle right here and a triangle right here. I wonder if we could be specific on the types of triangles, because this triangle actually has a right angle, so that's going to be a right triangle. Let's flip the page and see if we could. Oh look, there's another right triangle. So it says what 2 shapes were formed there. right here, what types of triangles are in the shapes that you made? And you're going to write alright. Right triangle. Okay, that's what we're going to put there. And it says what types of angles are in the shapes that you made. Okay, so we know we have right triangle, we have right angles. Let's look at the other angles within this shape. This angle right here, that doesn't look like a right angle. What kind of angle would that be? That's going to be an acute angle. Okay, there's an angle right here. It's going to be an acute angle. Let's move it around a little bit and see what we can figure out. Oh, that's going to be an acute angle, and that's going to be an acute angle. Okay, so what types of angles? So you pretty much have, in this, just looking at this one particular triangle right here, what do you have? You have two acute, angles, and you have one right angle. Okay, so within one of the triangles, okay, you have two acute angles. These are the two acute angles, and this is the right angle. Okay, all right. Let's go ahead and move on to number 5. Number 5 really, it gets you thinking, okay? So it says draw a quadrilateral, okay? So if you want to look at your quadrilateral family tree, if you want to look at your quadrilaterals that are listed here, let's see. Those are the ones that we have listed right there, okay? A quadrilateral that contains exactly one pair of perpendicular sides. Now remember, perpendicular from the last unit, perpendicular sides meant that two lines intersect that form 4 90-degree right angles, okay? So you're looking for a pair of those, which means there will be 2 total, okay, of perpendicular lines. Place X's on the perpendicular lines. All right, well, let's look and see, based on these polygons right here, let's look and see what we have got that could be a possibility. All right, so, excuse me, we have a rectangle. Let's see if I extended the rectangle's lines out. Oh, look, that forms a perpendicular. Here's perpendicular. Okay. But that's 2 pairs because there's a total of 4. So it couldn't be a rectangle. Okay, let's look at square. There's perpendicular. And I'm just extending the lines out of this figure. There's perpendicular. Again, we've got 4 total perpendicular lines, which would be 2 pairs. We're only looking for 1 pair. All right, so let's look at the parallelogram. All right, if I extended these lines out, and I'm actually going to do this in a different color so it shows up. If I extended this line out like this, and I extended this line out like this for this shape, they do intersect, but they do not intersect at a 90-degree angle. So they are not perpendicular. Okay, you can tell that this is an acute angle. You would need, in order for it to be perpendicular, you need to be a 90-degree angle 4 times right here. It's not. Okay, so I'll extend this one out as well, and this, again, that's intersecting, but this is not a 90-degree angle. This actually right here looks like an obtuse angle, and that looks like an acute. Okay, so parallelogram is probably not going to work for us. Let's look at our rhombus. If I extended these lines out with the rhombus and extended this one up, oh, it looks like they intersect, but do they form perpendicular? It does not look like right angles right here. That looks like an obtuse, and that looks like an acute. So that's probably not what we're looking for. I'm going to try it in another location. Extend that line out. Extend this line out. It looks like, again, they do not intersect. They intersect, but they don't intersect at a right angle. So they are not perpendicular. My trapezoid, I've got some stuff going on around here. I'm going to try and play with it a little bit on this paper, okay? And so trapezoid is one of the only polygons that we have not been able to eliminate. So let's just talk about what a trapezoid is. First of all, is it a four-sided figure? Yes, it meets that criteria. Okay. If you're looking at your polygon sheet, it says a quadrilateral with only one pair of parallel sides. So a quadrilateral, this would be something that you typically see that looks like this. That's something that a trapezoid typically looks like. However, a trapezoid can look different just depending on the shape that you draw. So basically it only has to have four sides and it only has to have one pair of parallel sides. Okay, it doesn't have to have a certain amount of angles, a certain amount of right angles. It doesn't have to have congruent. It doesn't have any of those stipulations. Therefore, we could draw a quadrilateral like this with a right angle. Let's see. That looks like a trapezoid. This is the more common trapezoid that you use, but let's look at this trapezoid. Let's see if this is even a trapezoid. In order for us to tell, number one, it has to have four sides. Does it have four sides? Yes, it does. Okay. The only other stipulation for a trapezoid is it has to have one pair of parallel sides. Well, is this side and this side parallel? Absolutely. If I extended those lines out, they would never touch. This side and this diagonal side, they would eventually meet and intersect. So again, this is still considered a trapezoid because it's only one pair of parallel lines. Those are the only two stipulations for a trapezoid. Therefore, this shape is going to be called a trapezoid. However, we're really looking for a pair of perpendicular sides. Okay, let's talk about that. I clearly see right here that we have a right angle formed, and right here we have a right angle formed. If we have right angles, then we more than likely have perpendicular sides. Oh, we sure do. There's perpendicular lines, and there's perpendicular lines. What about this? That does not look like it's perpendicular right here. And right here, that looks like it's like an acute and obtuse angle. So that, neither one of those. So therefore, we have one pair of perpendicular sides, a total of two. So there we go, there we go. All right. Place X's on the perpendicular sides. Okay, that would be, all right. All right, so if we look at number 6, it says Carlton sorts triangles into sets using one attribute. The videos discuss the word attribute. An attribute is a quality of a shape. You know, it just describes something that describes it, okay? So we're looking at all three of those figures, and they are triangles. So if you want to refresh yourself and just look back at all the different types of triangles that we have discussed, okay? It says draw another triangle that could belong to his set. So all of these triangles that Carlton has sorted have similar features. They have something in common. So let's first of all see if we can figure out what kind of triangles that Carlton has right there. Let's see. And, you know, these shapes can be, you know, sorted by angles or by sides. Well, we do know that triangles, all three have, triangles always have three sides, okay? Sometimes if the sides are all equal, they're equilateral. If the sides, two of them are equal, then they are isosceles. And if none of them are equal, they're scalene. They can also be sorted by the angles. And I clearly see some crazy looking angles in these shapes. I am looking at this particular triangle, and I see it's very obvious that there is an obtuse angle right there. So if I look back over at my notes, I see, oh, an obtuse triangle. It looks very similar to that. Okay, a triangle with one obtuse angle. That could be an option. I look here at this triangle and I see another obtuse triangle. Okay, I see that obtuse angle right there. It looks very similar to this one, just flipped over. So I think both of those are definitely obtuse triangles. Okay, this one in the middle, I'm not so sure about. I'm going to flip the paper around to see if it kind of helps me figure it out a little bit better. When I flip it around, I definitely see that that also is an obtuse triangle. Okay, there's an obtuse angle there. Okay, so it says it says what type of triangles did Carlton select? We're going to go ahead and write an obtuse. Obtuse triangles, okay? And then let's draw an obtuse triangle, okay? And so I want to show you how I would typically draw. I usually start with a straight edge, and then I'm going to make that obtuse angle. So I know it's going to be more than 90 degrees. There's an obtuse angle, and I'm going to fill in the triangle right there. Okay. So that is definitely an obtuse triangle that would fit with Carlton's sort. And finally, let's look at number 3. It says, write a true statement about the sides in these figures. And again, we're just looking at the sides right here. Well, obviously, both figure A and B both have 4 sides. So I'm going to say both figures sides, and let's see, what else can I say about the sides of the figure? Looks like all the sides are the same length. Do they all have the same, all these sides are the same? Yeah. See, both figures have 4 sides, and let's see, all 4 sides, and all sides are congruent. And you can even say that they're all parallel. Okay. The next one says, write a true statement about the angles in the 2 figures. Okay, so let's look at the angles this time. So I told you there's 2 ways to classify. You can classify by angles and by sides. Let's look at the angles within these shapes. I definitely see a right angle. There's 4 right angles. Let's flip this one around. Yep, and there's 4 right angles in there. So I would say that both figures have 4 right angles. Alright, so let's flip it over. And there is tons of vocabulary for this unit. Excuse me. However, if you have filled out the quadrilateral tree, the polygon page, the triangle page, almost all of those vocabulary words have been covered. I do want to go over just a few with you that may not have been covered. A polygon is any closed figure. Okay, so if it looks like that, and it's not a polygon because it's got to be a closed figure. Okay, an attribute again is a property or quality of a shape. Okay, you have attributes that describe you, the way you look. So the color hair you have, the same type of thing. The attribute is a property or quality that is describing shapes. A two-dimensional figure is a flat figure. It's not three-dimensional, so all the figures that we are discussing are two-dimensional. Let's see if I need to cover anything else. Okay. All right. So, vocabulary activity. This activity is very similar to this polygon sheet. So a lot of the stuff that we have already discussed on this will be right here for you to fill out. Okay. So it says complete the table to show the attributes of each polygon pictured. Circle the number if the polygon must have the attribute by definition. So what I would like you to do is hit pause on this video and fill it out to the best of your ability. And then when you have finished filling it out, you can come back and check and make sure that your table is correct. I'm going to go ahead and go over the answers with you. So a trapezoid, number of right angles. This particular trapezoid has none. Okay. Number of acute angles. Okay, there's an acute and there's an acute. There's two acute angles. Number of obtuse angles. There's an obtuse and there's an obtuse. Pairs of parallel sides. Remember, pairs means two total. Okay, so there's only one pair needed. And pairs of perpendicular sides. Okay, there's none right here. It says that you need to circle if the polygon must have that attribute by definition. Okay, so remember whenever we were doing one of the previous activities, I think it was number 5. Number 5 is a trapezoid. This particular trapezoid does have perpendicular sides and it does have right angles. So something that is a requirement for it to be a trapezoid, the only thing that is required is one pair of parallel sides. And so I'm going to circle that because that is the requirement. And you must have that to have a trapezoid. Okay? Alright, so let's continue. A parallelogram. Okay? This is a parallelogram. How many right angles? Never going to have right angles. Okay? How many acute angles? It's going to have 2 acute. It has 2 obtuse. 2 pairs of parallel sides. Okay. And 0 perpendicular sides. Alright, so let's go back and look at the requirements for a parallelogram. Quadrilateral with opposite sides. I'm sorry, what am I going to write? Yep. Opposite sides parallel and congruent. Let's think about that. Opposite sides parallel and congruent. Well, that must mean that the only thing that I really read in that was that the opposite sides are parallel. That is a requirement. So you must have 2 pairs of parallel sides. Okay? Alright, so let's look at a rectangle. Number of right angles. 1, 2, 3, 4 right angles. Okay? It's going to be 0 acute angles because all my angles are already taken. So I know I'm going to have 0 acute and 0 obtuse. Pairs of parallel sides. Well, there's a pair and there's a pair. So there's 2 pairs total. Pairs of perpendicular sides. And there's a pair of perpendicular sides. Oh, okay. So there's going to be 4 pairs there. And then we need to circle the requirement for a rectangle. A rectangle will always have 4 right angles. It will always have 0 acute angles. It will always have 0 obtuse angles. It will always have 2 pairs of parallel sides. And it will always have 4 perpendicular sides because of the 4 right angles. Okay? So it's important that you know that. Let's look at the rhombus. Okay? So looking at the rhombus right here pictured, you have how many right angles? 0 right angles. You have 2 acute angles, 2 obtuse angles, pairs of parallel sides. Let's see, there's parallel sides, there's parallel sides, so there's 2 pairs. Okay, and perpendicular. Well, because you don't have right angles, you can't have perpendicular, so it's going to be 0. Okay, and then let's look at the requirements for a rhombus. If you go back to the sheet, it says rhombus a quadrilateral with all sides congruent and opposite sides parallel. Again, let's see. All it really says is parallel, so you need to make sure that you have that. Perfect. I hope you got that right. Let's look at the journal portion. It says Mr. DeBull tells his students every rectangle is a parallelogram. Okay, I'm going to show you this. Every rectangle is a parallelogram, but not every parallelogram is a rectangle. Explain what Mr. Duval means. Okay. I would recommend you stop the video now and try and do that journal portion by yourself. You really need to think about what it means. And then I would pause the video, fill it out, and then come back, and I will be glad to write it down for you. All right, so it says, I definitely don't want you to think yours is wrong if you don't necessarily have exactly what I have, but it should say something along the lines of parallelograms must have two pairs of parallel sides which is true of all rectangles as well. Okay, so let's think about what that sentence means. Parallelograms, the only thing that they have to have is two pairs of parallel sides. That is true for rectangles as well. Okay? I would say, however, all the angles in a rectangle are right angles. Which makes it a special parallelogram. Okay. All right, so I want you to complete the partner practice, and then I want you to put your answers into the Google form with your partner practice just to make sure you get them right before you proceed with the rest of the unit. I do want to point out some help for you right here. Okay. You are looking at number 3. You want to make sure that it says which statement about the figures is not true. That means 3 of them are going to be true and 1 of them is false. You are looking for the false answer. The same thing with number 6. It says which statement about the square is not true. That means 3 of them are true, only 1 of them is false, and that's the answer you are looking for. I do want to point out in your partner practice number 1, let's see, it says, oh, okay, there it is, number 2. It's asking you which streets appear to form a right triangle. Okay, I don't want you to think that it's just referring to an angle. You actually would see a right triangle when you look at this diagram. Okay, I hope this helps. Thanks for watching.